Well, greetings, Mr. Kolazar's class. We're going to continue section 4.3, and we're going to be looking at isotopes, and we're also going to be looking at finding the number of neutrons. Now, as we continue in isotopes in section 4.3, isotopes, iso means the same, topes means form, and what we're going to look at is elements with a different number of neutrons. So it's going to be the same element, but the neutron number is going to change. So our number of protons is the same. Protons and neutrons give us the mass of the atom. Isotopes vary in the amount of neutrons, so their mass is going to be different. Protons, the P positives, are going to be the same. So it's the same element. It just has a little bit more or a little bit less mass. Now, all isotopes of the same element have the same properties still. So chemically, they're the same. It's just they're a little heavier or a little bit lighter. Now, what we're going to look at on your periodic table, the mass number is a number of protons plus the number of neutrons. So it's the mass of the atom. Now, remember, as we're going, we want to round this number to the nearest whole number. So please put this into your notes. Round the mass number to the nearest whole number. We'll look at why it's a decimal point later on. Now, when we're looking here, protons plus neutrons, this is almost the entire mass of the atom. We take out the electrons because it weighs so little in comparison. Number 5 in your notes, explain why isotopes of the same element can have different masses. The number of protons is different. We keep the same number of, number of neutrons. We keep the same number of protons, but the number of neutrons is what's different for isotopes. So like copper, example, copper has 29 protons. That's what makes it copper. But one element of copper can have 34 neutrons and the other one 36 neutrons. So copper 65 is just slightly more heavy than copper 63. Chemically, they're the same though. Now, a couple things that we can tell from our writing out the element nomenclature, ways to write it out. For different isotopes, we could have the carbon tells you the element name or the symbol. The mass number is going to be the number that follows each one. Or, in specific cases, if we're also given the second number below it, would be the atomic number, number of protons. Remember, the mass number is protons and neutrons. And then atomic number is just number of protons. So that's going to be ways that we can see different ways to write out our element names. Now, all of this information, if you know, you can give in the atomic number. Remember, the atomic number tells you the number of protons and the number of electrons. So if you know the name of the element directly, you can find this information. Now we have to do a little bit of work to get to the number of neutrons. So the one that we know right away, if you know the name of the element, you can find the atomic number on the periodic table or vice versa. So only one element on the periodic table has an atomic number 11. Mass number then can be found on the periodic table. Remember, we're going to round that number. Getting a little bit off there. Number of protons is the atomic number by definition, and it's also the number of electrons. So by definition, those three can be filled out. The last part then is to find the number of neutrons. Remember, our mass number so that mass number is going to be the number of protons plus the number of neutrons. So when we look at this mass number to find the number of neutrons, what we're going to do is you're going to take the mass number minus the atomic number will give you that difference, will be the number of neutrons. And this is what we're going to start focusing on in class the next couple days. So as you get your periodic table, remember we'll always have the PT to help us out. And as you use that periodic table, the one number you need, the number of neutrons, is going to be able to be followed and found there. We'll work through this one in class to make sure that you're on the right track, but as you work through these problems, we're going to be needing to solve those answers to find out which element we have and the number of protons, neutrons, and electrons for that element. The last little piece, just to show, when we look at isotopes, just as a quick explanation, hydrogen 1, 2, and 3. Now, hydrogen 1, 2, and 3, each one, nomenclature-wise, has a different mass, but all three of them have the same number of protons. Hydrogen 1 has just one proton. Now, if it has one proton, it has to have one electron. Now, when we look at mass number minus atomic number, hydrogen 1 minus 1 is 0, so the number of neutrons in the end is 0 for hydrogen. So hydrogen 1 is just one little proton in the nucleus and one electron outside the nucleus orbiting around with no neutrons in the center. Now hydrogen 2 has a mass number of 2, so that means that we'd still have one proton and one electron, but now we also include one neutron. So when we look at the mass number, this time we would have one neutron neutral, one proton the positive in the nucleus, and one electron orbiting around. And finally, hydrogen 3 would give us 2 neutrons, 3 minus 1 is 2, in the nucleus, and still just the one electron orbiting around. So isotopes, same number of protons, different number of neutrons. In natural occurrences, isotopes, all elements that have isotopes occur in natural ratios or abundance percentage-wise. So an example is copper has 2 isotopes. One isotope of copper is 30%, copper 65, and the other isotope of copper 69.2% is copper 63. So when we look at those two isotopes, naturally occurring, 30% is one, 70% almost is the other, and what we're going to start talking about later on is a weighted average for those. But isotopes occur naturally in those different ratios.